The KLM 787 was once praised as a symbol of safety and cutting-edge long-haul aviation technology in Europe. However, all those praises only exist on paper, because recently a maintenance engineer discovered an extremely dangerous fuel leak, located right next to a bundle of high-voltage wires, capable of causing the aircraft wing to erupt into flames at an altitude of 10,000 meters. But things did not stop there. When the technical team continued a deeper inspection, they uncovered even more serious flaws that could paralyze the entire operating system in an instant. The question is, why did Boeing allow such aircraft to leave the production line without a final thorough inspection? Is this just a rare incident? Or are there numerous hidden defects behind that KLM 787 that were never disclosed? Today's video will reveal the entire truth. The KLM 787 was once seen as a symbol of modern aviation, long-haul, smooth, fuel-efficient, and operated by one of the most trusted airlines in Europe. For many years, it was the pride of KLM and the top choice for intercontinental journeys. But then, during a routine inspection that seemed purely procedural, engineers discovered details that even they could hardly believe. The first discovery was a fuel leak inside the wing compartment. A faint damp trace appeared at the junction between the refueling valve and the pressure control unit, located right next to the electrical wiring bundle that powers the air conditioning and anti-icing systems. This is one of the most sensitive areas in the entire wing structure. An engineer confirmed just one electrical spark at this spot, and the risk of fire spreading through the wing structure would be completely uncontrollable. The leak didn't drip, but slowly spread along microcracks surrounding the fuel tube, a lightweight aluminum alloy pipe manufactured at Boeing's Charleston factory. This was also the site previously accused of shortening inspection procedures and skipping ultrasonic material scanning. According to the internal report, 6 out of 7 planes checked showed micro-leaks in the exact same spot. No technician error, no maintenance mistake. All 6 were serviced in full accordance with Boeing's official technical documentation. This means the issue did not originate at the scene. It started from the design, or from the production line, or both. And most concerning of all, these aircraft had already been put into commercial operation before the issue was discovered. But that was not the end. The second malfunction was found deeper, inside the engine. On November 19, 2023, Flight KL871 from Amsterdam to Osaka had to turn back after 43 minutes due to unusual vibrations from the right engine. A high-pitched metallic screech lasted more than 25 seconds, and the entire cockpit recorded vibration levels exceeding the safety threshold. The 787 made an emergency landing. Inspection results showed that the turbine shaft was misaligned by 0.03 millimeter, a small number, but at a rotation speed of over 10,000 revolutions per minute. This deviation could cause imbalance, local overheating, and potentially a turbine explosion if prolonged. An engineer stated, if the plane hadn't turned back in time, no one could guarantee what might have happened in midair. This engine unit had been in operation for less than 18 months. No warning signs, no wear indicators, and it had passed all of Boeing's inspection steps. So why did the failure still occur? From 2018 to 2020, ANA, Norwegian Air, and Air New Zealand had to ground several 787 aircraft due to similar issues with the Trent 1000 engine series. At that time, Boeing promised the problem had been fully resolved, but with KLM's fleet, the issue returned, as if no solution had ever been implemented. Worse, even more serious problems continued to emerge. The third malfunction involved the cargo hold fire detection system. In at least 3 flights, smoke sensors triggered continuous warnings despite the absence of heat or fire. All 3 flights had to return for inspection, with the final conclusion being sensor malfunction. But instead of replacing the faulty sensors, the technical team chose a simpler option, disabling the entire lower cargo fire alarm system. The aircraft continued flying as usual. No passengers were informed. No notes appeared in the post-flight reports. If an actual fire occurred, there would be no alarms, no signal. and no time to respond. In less than 8 minutes, flames from the lower hold could burn through the entire cabin floor. What's worth noting, this is not a problem unique to KLM. The smoke detection system provided by Boeing for the 787 series had been reported to have a high false alarm rate since 2020. Qatar Airways, LATAM, and ANA had all submitted requests for replacement. In response, Boeing issued only a technical bulletin. No recall, no mandatory upgrade. Boeing knew the system had flaws, but when the sensors gave false alerts, the solution was not repair. They simply turned the entire system off. You wouldn't believe it, because the failures didn't stop there. Woes! The fourth issue was found in the midsection of the fuselage, emergency exit door number 3. During an internal safety drill in February 2024, technicians discovered that emergency door 3 could not fully open when the aircraft was in a power-off state. The handle still functioned. The mechanical lock still disengaged, but the door only moved partially, then stopped. According to design, the emergency exit on Boeing 787 operates on a dual system, electric and manual. If the two mechanisms are not synchronized, the system automatically locks to prevent incorrect decompression. However, in a power outage, when cabin pressure is already 0, the door should fully open. It didn't. No warning was issued. No emergency instruction was mentioned in the technical documentation. Only one short note from the maintenance team: mechanical travel incomplete. Under normal conditions, this might seem like a minor issue, but in a scenario of mid-cabin fire, thick smoke, and passengers crowding toward the center, this would be the only exit at that point. If the door jams, dozens of people could be trapped. Notably, the door locking mechanism was manufactured by a subcontractor in Italy, a company previously investigated in 2019 for producing incorrectly sized bearings that caused similar failures on some Boeing 777 aircraft. Internal documents show that Boeing had prior knowledge of potential desynchronization between mechanical and electrical systems during power loss. But no technical updates were sent to the airlines. The doors were still approved. The aircraft were still delivered, and those very doors, to this day, are still flying. But the door was not the only component to fail during an emergency scenario. When the exit does not open in time, people instinctively look for light. But on the Boeing 787, light becomes another problem. During an internal training flight in late 2024, the crew noticed that the LED emergency lighting system did not operate in sync across cabin zones. The front cabin lit up 2-3 seconds earlier. The mid-cabin flickered irregularly, and the rear cabin remained completely dark for the first 7 seconds. This lighting system is programmed to activate automatically during a power outage, guiding passengers in darkness or smoke. But when the lights are out of sync, confusion takes over. In a simulated evacuation test, 15 participants ran in the wrong direction, simply because the mid-cabin lights didn't turn on in time. The recorded outcome was clear. The risk of trampling, pushing, and behavioral panic increased significantly. The issue was not light intensity, but signal delays between independent lighting controllers across cabin zones. One engineer stated, "We don't understand why the lighting system wasn't synchronized from the manufacturer." To this day, Boeing has issued no official technical response, no software update, no temporary handling instruction. The fault remains classified as not affecting operational capability. In the cabin, passengers may be confused by the lights. But in the cockpit, pilots face something more dangerous: cold. Not an air conditioning failure, not a configuration error, but a real technical problem. On at least 2 flights operated by KLM, the cockpit temperature dropped below 10 degrees Celsius while the aircraft was cruising at 35,000 feet. The drop did not come from the outside air. It originated from a high-pressure cold air leak just behind the cockpit wall, where the air conditioning, air supply, and pressurization systems connect. The cold air escaped in sync with the compression cycle. Not loud, not forceful, but enough to make the control column freezing cold. The screens fogged, and the pilots' faces begin to lose sensation. Pilots were still able to fly, but no one knew how long they had been shivering with delayed reflexes, thousands of feet in the air. According to maintenance documentation, the auxiliary pressurization system on some 787 models had been adjusted due to faulty rubber gaskets. But for the KLM aircraft, no updates were applied. No warning was triggered, even when the cockpit temperature dropped below the allowable threshold. One flight crew wrote in the report, "We couldn't doze off because our hands were too cold to hold the throttle. And the final question is no longer, where did the fault come from? But if concentration is lost for just 5 minutes, what could happen? From fuel leaks, abnormal engine vibrations, to emergency doors failing to open, misaligned lighting systems, and cockpit temperatures falling below safe limits. Each of these issues alone is enough to place any airline in a state of emergency. But the most terrifying thing isn't technical. It lies in this. All of these failures occurred simultaneously, on multiple aircraft, with the same characteristics, and when the engineering team traced everything back to the source, they uncovered a chilling truth. The problem did not originate from KLM. The origin of these failures began at the very place where the aircraft were born. The technical issues on the KLM 787 fleet did not occur randomly. They did not stem from human error, nor were they the result of excessive aircraft age. They repeated, same positions, same structures, same manufacturer, and all of them led to one place, Charleston, South Carolina. This is Boeing's main assembly plant for the 787 series, a facility built not to improve quality control, but to accelerate production, to meet thousands of orders placed after the Dreamliner was launched as a technological marvel. But at Charleston, the dream began to fracture. One 787 left the line with passenger seats misaligned from the locking pins. Another had an electrical unit near the cargo hold that wasn't properly secured, and the one delivered to KLM, according to internal records, had bolts at the crew seating base that were not tightened to proper torque, at a spot that endures constant impact during every landing. When KLM maintenance teams reported these anomalies, they discovered something more alarming. This wasn't the first time. All of these issues had previously been listed in internal complaint logs as far back as 2019, but were categorized as non-critical deviations. No one fixed them, no one took accountability, and the planes were still cleared for delivery. The greater danger lies in something invisible, composite material. The fuselage of the Boeing 787 is built from carbon fiber composite, a lightweight, durable, corrosion-resistant material. But that very property is what makes it hazardous. If the damage is internal, there is no way to detect it by eye or through conventional surface inspections. At KLM, during an in-depth ultrasonic inspection, the technical team discovered micro cracks at the joint between the fuselage and the wing. The cracks were not large, but located right at the load-bearing adhesive layer, where if the fracture extended just a few more millimeters, the entire structural integrity of the aircraft would be compromised. Boeing had previously known about the potential for defective material. 2 suppliers, one from Italy, one from Japan, had been internally classified as high-quality risk since 2021. But due to delivery pressure, the materials were still put into use. In the end, the most frightening thing wasn't the defects themselves. Boeing didn't deny the errors. They simply delayed the fixes, then fell disturbingly silent. When smoke detectors on the 787 began triggering false alarms as early as 2020, Boeing didn't issue a recall. They released an internal technical advisory, a suggestion, not a warning. No one was ordered to replace the system, no press conferences. And not a single passenger was told that, in the event of an actual fire, there might be no alarm, no alert, no chance to react. With the Trent 1000 engine defects, multiple airlines had already reported turbine cracks since 2018. Boeing promised it was being handled. Yet the planes kept being delivered, as long as they hadn't exploded yet. One whistleblower revealed that several errors were bundled together in reports to avoid triggering an official alert protocol. They didn't fix things. They waited. They dodged. They looked away. And worst of all, they normalized it. In an industry where a tiny flaw can cost hundreds of lives, that kind of silence isn't just negligence, it's complicity. When the world's largest aircraft manufacturer knowingly ships planes with faulty systems, planes that carry millions of passengers every day, with risks hidden deep in their wings, engines, emergency exits, and even cockpits, that is no longer a technical failure. That is a crime wrapped in reputation and profit. And if Boeing doesn't stop, who will pay the price for their silence next? On May 14th, Schiphol Airport fell into an unusual state of chaos. That morning, KLM abruptly grounded its entire Boeing 787 fleet for emergency inspections following a series of serious technical findings. No press release, no warning, no explanation. 650 passengers at the international departure area only knew that their flights were delayed indefinitely. No announcements over the speakers, no messages from the airline. No one appeared to say why. On the electronic board, flights to New York, Shanghai, and Mexico City disappeared one by one, without reason, without replacement. Some sat on the floor, some broke into tears, some kept dialing their phones, searching for staff. But the service counters stood empty. All questions were left unanswered. A few passengers tried to reach the western maintenance zone of the airport, where the affected 787s were reportedly kept. Security stopped them. The doors remained shut. Reporters from 2 Dutch television stations present at the scene were also denied access. When they contacted KLM, they received only one line in response. Internal technical issue. No impact on flight safety. But everyone knew this technical issue was not caused by KLM. Every aircraft now being disassembled out there came from the same place, the same factory, the same corporation that once promised the Dreamliner would be the future of modern aviation. More than a decade after being introduced as a symbol of modern aviation technology, the Boeing 787 is now revealing cracks not only in its composite structure, but in the entire system of design, manufacturing, and technical oversight, from fuel leaks, turbine misalignment, deactivated fire sensors, jammed emergency exits, to synchronized lighting, to unusual cockpit temperature drops. Every sign points to one conclusion: these are no longer isolated incidents. When the same aircraft model repeats the same chain of failures across multiple airlines in different regions over many years, the question is no longer, is this aircraft safe? But, from start to finish, who signed the paper that allowed it to fly? And while passengers still board planes every day, fastening seat belts, pilots adjust their headsets, ground crews count down to departure, somewhere, Dreamliners are still flying with defects that even the manufacturer has never truly stopped to examine. If you found this video insightful, don't forget to like and subscribe to our channel so you won't miss future content. Share your thoughts in the comment section below. Thank you for watching until the end. And remember, everything we've presented here is for analysis and reference across multiple perspectives. Please cross-check with other sources for a more complete and objective understanding.